Look at our warm-up first, and then we'll talk about combinations versus permutations. The tricky part about these style of problems is knowing which one to apply. Now, it's pretty easy right now because we've only learned one of them, but this is a clear example of a permutation. How do we know it's an example of a permutation problem?
Because it's so you need order.
Yeah, so order is important here. Now, if we haven't dealt with combinations and permutations, we don't really know why that's important, but the order of which horse comes first, second and third matters in this scenario. So the first thing I need to do is identify, well, how many outcomes are there for the horse coming first, or for picking the first, second and third horse, for identifying the first, second and third horse. So, first place, how many horses do we have? 12 times 11 times 10. Okay, so that's our number of outcomes. We can write that, I shouldn't write number of outcomes, I'm just going to call that, give me a letter.
A.
P, we'll go with P, alright? So P equals number of outcomes. Now there's a better way of writing that, I probably shouldn't have used P, I'm going to use A, thanks for your suggestion. Harry. There's a better way of writing that. How can we write that rather than writing 12 times 11 times 10? Because that doesn't make much sense, does it?
12 factorial.
Well, A equals, before we get to that, you're right, your next line is 12 factorial, but
Over 9.
over 9 factorial. So that's probably 2 lines away from where we actually want to be. I'm missing some work in between now and there, but so we know that's where we want to be, but how do we get there? First line, 12p, 9, 3.
And then
12 factorial divided by 12 minus 3 factorial. Which equals 12 over 9 factorial. Cool. This is not how we do it anymore. Are we clear? That's a great way for introduction, but now that we've been introduced to permutations, we should be able to do that on our own. So what's the probability of me randomly selecting that outcome? Well, won't the probability, I'm just going to put probability of try, wouldn't that equal 1 over 8?
Yeah.
Yep. Because how many options do we get to pick the trifecta? How many chances do we get?
1.
How many outcomes are there?
8.
8 outcomes, which is 12 times 11 times 10. 12 times 11 is
132.
times 10.
20.
What's the probability?
So the probability will be 1 over,
I mean, like, what's the negative probability?
I'll just put probability of try, I'm calling it trifecta. And R in the middle, yep, it's a little 1. How do I get the 1320?
Yeah.
Put that in your calculator.
Exactly.
But why'd you put 1 over 9 first?
That's an A.
Oh. Yeah, that's what I was
And A is the,
number of outcomes.
very good.
Yeah, you got the probability.
Now in this scenario, and this is going to lead us into combinations, right? In this scenario, what have I done? What am I saying? Does anyone know what I'm asking? What this looks like? 12 horses in the race. I'm saying that horse number 3, horse number 7 and horse number 8 will come first, second, third. But I'm saying that the horse number 3 will come first. I'm saying that horse number 7 will come second. I'm saying horse number, whatever, 8 did I say before, will come third. What I'm not saying is that here are 3 horses, they're going to come first, second or third together. Does that make sense? So in this scenario, I'm saying I'm picking which horse is coming first, I'm picking which horse is coming second, I'm picking which horse is coming third. That's the probability of me doing that in a 12 horse race. If I said I've got 3 horses what's the probability that they come first, second, and third? And I don't care which horse comes first, I don't care which horse comes second, and I don't care which horse comes third, I just know that they're the three that are going to come first, second, and third. Does that improve or decrease my probability? Improve. How much? Well, how many more options do I get?
You get less options.
There are less options, correct? Well, there's probably still, are there less options? That's actually interesting. Are there less options? There is still more options, correct? There is still, sorry, the same number of options. What's different?
The amount of options are correct.
Yes. So let's have a think about how we can figure that out. We might need another example, but that's probably a little bit abstract for us to get our head around. We're probably not horse fanatics. We'll come to the right, I'll finish that video up and then we'll come to the right hand side of the board. We'll talk about combinations because it's going to rub out the middle section. So can we jot those notes down and then I will